All right, so for the rest of this week, we're going to look at section 2.1, which looks at angles, okay, how we measure them. There's two different types of units that we generally use. Okay, most calculators have the units built right in. Degrees, okay, I bet a lot of people are familiar with that. Radians is another way. Okay, maybe not as familiar, but we'll talk about it. And then tomorrow we'll look at some formulas that, in order to use them, we have to know how to convert to radians. All right, so I'm going to show you how to convert between radians and degrees today, and then we'll use that in a formula tomorrow. All right, so before we can talk about converting between degrees and radians or how we measure angles, I'm just going to define what an angle is. Okay, so basically, to do that, we got to start out with something even simpler, and that's a ray. Okay, so a ray is a portion of a line that has a starting point called a vertex, and it extends in one direction forever. Okay, if we take two rays, okay, and have them start at the same vertex, okay, give them a common starting point, we can create an angle. Okay, so there's a picture of an angle. Okay, basically, we take two rays, give them the same vertex, okay, common starting point, and then we just create an angle. Now, when we talk about shapes, okay, like triangles, we'll also refer to these as angles as well. Even though these sides are not rays, they're segments. Okay? They're still angles. But if we're going to sketch an angle just by itself as not part of a shape, this is generally how you do it. You draw two rays. Okay, and what we've done here is created two sides to the angle. Okay, there's an initial side, and then there's a terminal side. And basically, the way you can figure out which one is initial and which one is terminal is you go counterclockwise. Where you end up, that's the terminal. Where you start, that's the initial. Okay, so here's another diagram. Okay, so here's our initial side, and this is terminal. In a little bit, we're going to have a pretty easy way to figure out which side is initial and which side is terminal just by how we draw the angle. Okay, we're going to draw it a certain way. Does everybody have that top part? Okay. These two diagrams are the same, so you don't need both. Okay, so notice here the direction I have this arrow being drawn. Okay, if you think in terms of movement on a circle, how would you describe that direction? Yeah, that's counterclockwise. Okay, so if your rotation from the initial side to the terminal side is counterclockwise, okay, then that's a positive angle. Okay, so if you're rotating from the initial to the terminal in a counterclockwise direction, it's a positive angle. Okay, instead of going counterclockwise, what do you think would happen to your angle if you went clockwise the other way? Yeah, it would be negative. Okay, so if the rotation is clockwise, then the angle is negative. Generally, we don't like to measure angles as negative. Okay, because anytime you work with a negative, it just adds a little bit of complexity to what you're trying to do. So if we can, we try to work with positive angles. Okay, and I have a program I'm going to bring up, and I can just show you sketching different angles and show you how they either are positive or negative. Okay, so if you still need to copy this down, I'll put this right back up. Let me show you this. Okay, in this program, all I can do is move the terminal side. I can't move the initial. Okay, initial side is always on the positive x-axis. Okay, but as I start to move in a counterclockwise direction, notice it's measuring the angle positive. Okay? And it's measuring the angle in two different ways. Anybody know what units that top number is in? Yep, that's degrees because it's got the little circle. And we haven't talked about the bottom one yet, but we're going to. Does anyone know what the bottom one is? Does anyone remember what's the other way I showed you on the graphing calculator? The other way you can measure an angle? Radians. Yeah, very good. Okay, so we'll talk about radians in a little bit. Okay, and as I go, you can see the different angles. You also notice here that all of a sudden, instead of writing a decimal, it's switched to writing an answer in terms of pi. We'll talk about that too. Okay, some angles, as you're moving along, all of a sudden you might see it change to writing in terms of pi. Okay, so we'll talk about that. Okay, and then if I start going the other way, negative angle, now it's going clockwise. Other thing you can notice is sometimes there's always two ways to get to the same spot. Okay? If you want to get to negative 90, you can either go clockwise, okay, 90, or you could go counterclockwise, and that would be written as 270. Okay? So there's two different ways to end up at the same spot. And unless you draw the arrow in showing the direction, somebody wouldn't know, they wouldn't know the difference. The terminal side is in the same spot. Okay, what would happen if I keep going and then I stop back where I started? How many degrees would that be? Yeah, 360 degrees is one full circle. Okay, and if we keep going, now it's just getting bigger than 360. Okay, same thing in the negative direction as well. So to keep angles simple, we like to keep them positive, and we like to keep them between 0 and 360. Okay. All the angles that I was drawing in that program were all in standard position. Okay, two things have to happen if I ask you to sketch an angle in standard position. Okay, one, the vertex of your angle has to be at the origin. Okay, so you need a set of axes. You put your vertex right at the origin. Okay, second thing that has to happen, the initial side has to be on the positive x-axis. Okay, so vertex at the origin, initial side on the positive x-axis. That's an angle in standard position. It fits both criteria that I just said. Okay, and also every angle I just drew in that other program, they were all standard position. Okay, what if I did, what if I did that? What's wrong with that angle that it's not standard position now? Yeah, the vertex is not at the origin. Initial side is still where it needs to be. It's on the positive x-axis, but the vertex is not. Okay, what if I did that? Yeah, now the vertex is at the origin, that's good, but the initial side's not on the positive x-axis. That's not standard position. That is. Okay, so what that allows us to do is if I ask you to sketch an angle in standard position, then everybody should pretty much be sketching it in the same spot. Okay? Rather than maybe twisted or whatever. Okay, any questions on what it means to sketch an angle in standard position. All right, so that's kind of the background. That's all we're really going to talk about with the basics for angles. Okay, in the last part of class, we're going to talk about how we change from degrees to radians and radians to degrees. Okay, doing that is something we pretty much do all year. It's kind of like in Algebra 1 when you combine like terms or use the distributive property. It's a very basic thing, and it comes up all the time. Okay. All right, so earlier I asked you guys this. If you go all the way around, if you make one revolution, how many degrees is that? That's 360. Okay, so we know one revolution equals 360 degrees. But the question is, how many radians to go all the way around? Okay, if we can figure that out, then we can convert between degrees and radians. All we need is a connection between going all the way around the circle in degrees and going all the way around in radians. Okay, it's kind of like the connection, if I asked you to convert between feet and inches. All you need is a fact to start with, and then you can figure out other things. What's a good connection between feet and inches? What do you know? Yeah, there's 12 inches in 1 foot. So now if I said, how many feet is 100 inches? Well, you know this. So you can basically set up a proportion. And you could solve for x and figure out how many feet in 100 inches. But the key is you've got to know something to start with. Okay? So we're going to do something kind of on this idea. We're going to set up a fraction, not necessarily a proportion. Okay? But we have to know this fact. Okay, so we'll figure this out. Okay, we'll get to that. Okay, so if you look at the word radian, does it look like any other word? Kind of has a lot of first few letters in common with it.
Radius.
Radius. Okay, and that's a good starting point to talk about what a radian is. Okay, so radius comes up when we start talking about circles. Okay, so I've drawn a circle here. And inside that circle, I drew an angle. And the two rays of the angle hit the circumference here and here. Between those 2 points I just drew, okay, I connected them, and that's called an arc. Okay, an arc is just part of a circle. Okay, and if we have an arc that goes all the way around the circle, usually we call that the circumference. Okay, we use the word arc when we're just talking about part of the circumference, but I guess technically you could say this. The circumference, it's just an arc, but it takes up the whole circle. All right, so this is what a radian would look like visually. If you draw an angle, okay, and let's say you measured this arc in red with a piece of string, okay, and then you measured this radius. If the size of this arc and the size of the radius come out exactly the same, then what you've just drawn is an angle that is 1 radian. Notice I didn't label RAD because when we're using radians, we usually don't. The only time you put a label is if you want degrees. Okay? You put the little circle. All right, so if you draw an angle and the size of this arc just happened to come out exactly the same as the size of the radius, you just drew an angle that is 1 radian. Okay, so that's kind of the connection between the word radius and the word radian. It still doesn't really help us convert between degrees and radians, but it kind of gives you a visual for what a radian looks like. Okay, any questions on that? Okay, this idea we're going to come back to tomorrow. So this is, make sure you have that because that's important for a formula we're going to talk about. All right. This fact is what's going to help us to convert between radians and degrees. Okay, we're not going to go through the explanation why this is true. We're just going to use this as our starting point to figure it out. Okay, and the statement says that an angle's measurement in radians is equal to the length of the arc. So if you measure an angle in radians, you write that number down, and then you measure the arc, and you write that number down, they're going to come out exactly the same, as long as you use a certain type of circle. Okay, and the type of circle that this very special kind of thing happens on is called a unit circle. Okay, unit circle is a circle with a certain radius. Does anybody have a guess what the radius might be on a unit circle? Think of the simplest number you could have for a radius. Yeah, 1. That's all a unit circle is. Okay, circle with radius 1. Okay. So again, measure the angle in radians, write that number down. Measure the length of the arc, write that number down. I guarantee you those two numbers are going to come out exactly the same, as long as you measure it on a unit circle. Okay, so what that means is, if we can figure out the size of an arc, we automatically know the size of the angle, because they're the same, right? And that's what's going to help us figure something out, because we already know something about the size of an arc on a circle. Okay. So I want to think of an arc that's so big it takes up the entire circle. Okay, what did I say earlier you normally call that? If it's an arc that goes all the way around a circle? It's the circumference. Now, if we can figure out the circumference of the unit circle, we'll automatically know the angle that goes all the way around, because they're exactly the same. Okay? So, does anyone remember the formula for circumference? Yeah? Yeah, it's 2 pi r. Okay? So I'm going to find the length of the arc that goes all the way around the circle. We call that the circumference. And once I have that, it's exactly the same as the angle in radians. That's the key. Okay? So in this formula, what am I letting my radius be if I'm doing it on a unit circle? 1. Okay, so fill that in. So the circumference of the unit circle is 2 pi. That circumference is exactly the same as the angle in radians. So if the circumference is 2 pi, then the angle is also 2 pi. So we just figured out how many radians to go all the way around the circle. 2 pi. Now we've got a connection between degrees and radians, just like we had a connection between inches and feet. We know 360 degrees equals 2 pi radians. Okay, and you may have seen that if you watched me when I was using the program, okay, on the browser. If I go 360 degrees, it writes 2 pi radians. All right. So that's fine. We could set up proportions if we wanted. We could say something like, in 360 degrees, there's 2 pi radians. Okay, you don't have to copy this part down. And let's say I said to you, I have 100 degrees. How many radians is that? You could set up a proportion, just like feet and inches. You just needed this starting fact, which now we have. Okay. The only thing I'd like to do is reduce these numbers if we can. Okay. Does anybody see a number we could divide both sides by? Yeah, we could make this conversion a little smaller. So 360 equals 2 pi. 180 equals 1 pi. So if you go halfway around the circle, that's pi radians. Okay, and I can show you that on here as well. If I can line it up, 180 degrees is pi. All right, so that conversion, okay, is fine. It's a little simpler, but anytime you give someone a conversion, okay, like you guys gave me this one earlier, there's usually a certain number in a conversion. Okay, so here's a few conversions. Okay, you tell me what number is in all these conversions. In 1 foot, there's 12 inches. In 1 day, 24 hours. 1 minute, 60 seconds. 1 year, 365 days. Not this year, but most years. What number is in all those conversions? 1. Okay, usually when you give someone a conversion, you don't say in 3 feet there's 36 inches. That's true, but there's an easier way to say it. Just say in 1 foot there's 12 inches. Okay, so what I'd like to do is get a 1. And let's start by getting a 1 on this left-hand side. Okay, what could I divide both sides by to make the left-hand side 1? Divide by 180. Okay, and that tells me that in 1 degree, there are pi divided by 180 radians. And now, what if I wanted to know 2 degrees equals how many radians? What could I multiply each side by?
2.
Yeah. If you multiplied this by 2, multiplied that by 2, now in 2 degrees, it's 2 pi over 180. What if I wanted to know 5 degrees? What would I multiply by? Yeah, if you multiply each side by 5. So the trick here is you take your angle you want to convert. Okay. You end up multiplying your angle by pi. Okay, that's step 1. Multiply your angle by pi. Step 2, divide by 180. Okay, those are the 2 steps to change from degrees to radians. So instead of setting up a proportion every time, we're just shortening it to 2 steps, simple steps. Multiply by pi, divide by 180. And that's to change degrees to radians. Okay, does everyone have those 2 steps? All right, so now, last thing I want to figure out is how to convert the other way, okay, radians to degrees. Okay, to do that, I'm going to go back to that equation I had. 180 degrees equals pi radians. Okay, where did we get the 1 last time? Did we do it on the left or did we do it on the right? Did it on the left? Let's do it on the right this time. Okay, what would I divide each side by to get a 1 on this side? Pi. And pi. Okay, so now that says 180 degrees divided by pi equals 1 radian. So now if you wanted, you could actually take 180, divide by 3.14, and that's how many degrees are in a radian. Okay, it's 50 something. All right? Same question I asked last time. Okay, what if I wanted to know 3 radians is how many degrees? What would I do to each side? Just triple that. Triple that. Now you have a formula for 3 radians. What if I wanted to know, I don't know, 6 radians? Multiply by 6. Multiply by 6. Okay, so looking at that, anybody think they see the two steps that you have to do here? Take your angle and do what with it? Multiply it by 180, and then step 2, divide by pi. It's very similar to converting the other way. It's just you're switching what you multiply and divide by. Okay, so now if we can memorize these 2 steps, we don't have to go back each time and think about the circumference of the circle and all that stuff. That was just to figure out how we do it. Okay, that was just our starting point. This is what's important. Okay, change radians to degrees and degrees to radians. Okay, questions on those? Yeah, we'll try some examples now. Any questions? Yes.
What's the point of like changing like a degree into radians?
Some of the formulas that we use, they only work if your things are in radians. So tomorrow we're going to learn a formula that if they give us an angle in degrees to start with, it won't work. We have to change to radians in that formula. So some formulas, and most higher level math classes, they don't use degrees. Like if you ever take calculus, almost nothing is done in degrees, which is kind of strange because degrees is probably what you're used to. It's what you've used, kind of makes sense. Why mess with it? But to do more complicated things, degrees actually makes things harder. Radians is easier once you get familiar with it. All right. What was that? All right, so let's try converting 60 degrees to radians. Now, anytime you're converting between degrees and radians, you always have 2 choices. It's either pi over 180 or 180 over pi. Okay, you can look back at your notes and read the steps. Okay, or let me give you a way you can think about it without having to memorize anything. Okay, think of your angle like that. Okay, it's 60 degrees over 1. Okay, degrees is in the top. We're trying to get rid of degrees and convert to radians. Where would degrees have to go to cancel out? It would have to go on the bottom. Okay, and now when you think degrees, the number I want you to always think of when you think degrees, think 180, because 180 had the degree symbol. When you think radians, I want you to think pi. Okay? Because pi had the label of radians. So when you see degrees, think 180. You see radians, think pi. So let's go back here. Okay, we just said degrees has to go on the bottom to cancel out, which means radians has to be in the top. What number did I say to think of when you see degrees? So the 180 goes there. How about radians? Pi. And if you look at the steps we just wrote, it is multiply by pi and divide by 180 to change to radians. But I never memorize that. Okay? I just look at my units, and whatever unit I want to cancel out, put it in the bottom. Now I'm left with radians. Okay, 2 choices. Either multiply straight across or reduce first. I would probably reduce first. Okay. Is there any number that goes into both 60 and 180? 60. 60 goes into 60 once, goes into 180 3 times. So I'm left with 1 times pi. You can write 1 pi or just write pi. Okay? And in the bottom, I'm left with 1 times 3. And that's it. That's your final answer. Okay, we don't normally write RAD. Okay, so I'm going to stop writing it because we have to get used to not seeing that. Only time you put a label is if they want degrees. Okay, radians you don't. Okay, questions on that? Okay, if they don't ask you to round, don't worry about it. Just leave it as pi over 3. If they want you to round, they'll say it. Okay. All right, let's try 150. Right, so Zena, we've got degrees. We're trying to cancel it out and get radians. So where would degrees go to cancel? In the bottom. And what number always goes with degrees? There's your 180. That means radians is in the top. And that's pi. Okay, I'm not going to put RAD this time. Okay, so degrees cancels out. And Shane, do you see a number that goes into both 150 and 180?
Oh, 10, sorry.
Yep. You could start with 10, which is going to take off the zeros. And does anybody see a number that goes into both 15 and 18? Now you can reduce by 3. 3 times 5 is 15. 3 times 6 is 18. So if I simplify that, what would my final answer be? Yeah.
5 pi over 6.
Good. 5 pi over 6. Does anybody see what 150 and 60 are both multiples of? Has to do with an angle that's in a special right triangle. Not 90, but you're thinking of the right triangle. 30, yeah. Just 30, 60, 90. Any angle that's a multiple of 30 is going to be written nicely with pi. Okay, so if we go to 30, you can see it changes to pi over 6. If I go to 60, it's pi over 3. In fact, 45 is also written nicely. Okay, it turns out this calculator will do anything that's a multiple of 15 as a nice answer. Okay, generally on our tests, any angle that comes out as a multiple of 30 or 45, that's when we'll write it as a nice answer. If it's an angle like 112.6 degrees, that's not going to be a nice answer. Okay, so if we had something like that, I can't do the decimal, but if I could get to 112.6, we would just write it as a decimal. Okay. All right, so try that one on your own. Okay, doesn't change anything because it's negative. Just don't forget your final answer should also be negative. Okay, remember, if the answer starts out negative, it's going to finish negative. Okay, that negative's not going to disappear. Okay, degrees on top. Put degrees on bottom. Pi on top. And a lot of people tried reducing by 5, that's fine, or 15. But there's an even bigger number that goes into both. Anybody see the biggest one? Yep. 45. 45 goes into that once. Goes into that 4 times. And I'm left with negative 1 pi. Okay, what I would do is just write it negative pi. Okay, divided by 4. Okay, any questions on that one? All right, this one I think I'm going to skip over. Okay, if you wanted to do it out, you would get pi over 2. So if you want to check that or practice it, studying for the tests, that's fine. But let's try one where we have to round. Let's try this one, 107. Okay, and we'll do it to 2 decimal places. Okay, one way to tell this is a problem you probably should round is this is not a multiple of 30 or 45. But you're not going to have to guess on the test. The directions will be very clear, either to round or leave it exact. All right, so we're going to do the same thing we've been doing, except the last step, we're going to type it in. Okay, divide by 180, multiply by pi. Now, because you're going to type it in, I wouldn't bother reducing this at all. That's just a chance to make a mistake. Just type it in the way it is. Okay, also, when you type it in, okay, I'd like you to use the pi button. I'll show you why on the next problem, but okay, just use the pi button. pi divided by 180. Okay, so we get about 1.87. Should I put RAD on the end? No. That's understood to be a radian if it's not labeled. Okay, so any questions on changing degrees to radians? Okay, this is the more important way to convert. Okay, converting the other way, radians to degrees, that might be helpful. Like if I said to you, I want you to visualize this angle, pi over 6. Well, I bet once we change it to degrees, everybody will have an idea of how big it is, but maybe you don't right now. Okay, changing to degrees would give you an idea. All right, so just to start out, I put RAD the first time, but you've got to get used to not seeing that. Okay, we got radians in the top. Colby, I'm trying to cancel out radians, get degrees. So where would radians go in this fraction? On the bottom. Okay, and the number that we always think of when we think radians? That's the pi. So degrees goes on top. And Tyler, what's the number we think of when we think degrees?
180.
There's my 180. And now there's a few things here that cancel out. Rhiannon, do you see what one thing that cancels? The pi's cancel. Okay, anything else that's going to disappear completely? There's something that's going to reduce too. Something else that's it's actually just going to disappear. Radians. Okay, that's going to be invisible in the next problem, so just that'll cross out. And now people said this reduces. 6 goes into 180 30 times. Okay, if you can't do that, you always use your calculator. Or just think in your head, 6 goes into 18 how many times? And then add a 0. Okay, so what's my final answer here? 30. Okay, so pi over 6 radians is 30 degrees. Questions on that one? Okay, we'll try this one, and then if I have one, I'll have you guys try one on your own. Okay, Adam, you think you could tell me what I got to do here?
I gotta put 180 on the top.
Yep. And is that degree or radian?
Degree.
Do I need a label?
Well, if you want, I guess.
Well, it's a degree.
Yeah.
So anytime you have a degree, yes, you have to put a label. Yep. And what goes on the bottom? And what? Pi. Do I need a label there? No. Okay, so radians is gone. Pi is gone. Okay, should I multiply, or is there anything else I could reduce first? 2. The 2? 2 goes into 180 90 times. So what am I left with for an answer here? 270. 3 times 90. And again, it's degrees, you need the label. Okay, questions on that one? Does anybody feel like they need to try this one on their own? We're okay? Okay, so if we're okay, I'll skip that one. I'll just tell you the answer. It would be negative 135. Okay, so if you want to try it, to practice for the test, you can just double check, make sure that's what you get. All right, and last one, we'll do a round to 2 decimal places. Okay, not always, but a lot of times if pi is missing from the question, the answer is going to come out messy. Okay. this had pi in it, it would cancel, the answer comes out nice. The one before it had pi, pi's cancel, the answer comes out nice. There's no pi here. Okay, so the pi is not going to cancel. So it doesn't come out nice. Okay, so same step as last time. 180 on the top, pi on the bottom. Okay, this time I'll show you what happens if you use the pi button, which is how I'd like you to do it, and then if you do 3.14 instead. Okay, so I'm going to do 3 times 180. That's 540. And now divide by pi. So we get 171.89. So if I was looking for an answer on the test rounded to 2 decimal places, that is what I would accept. Okay, not 0.88. Okay, you need to make sure you round properly. All right, let's see what happens if we do the same thing but divide by 3.14. Okay, this I don't want you to do it this way. I'll show you what happens. Okay, we get 171.97. Okay, 88 and 97, that's quite a bit off. Okay, it's not like 88 and 89. So using 3.14 is not accurate enough. Okay, so make sure you use the pi button. Questions on that? Cool. So we took a look at how to change between radians and degrees. Most important thing for today is how to change to radians. Changing to degrees is fine, but not as important as what we did first. Okay, so the homework, it's on page 99. It's 36 to 68 even. Okay, some of the problems, they're going to say leave the answer exact. That means don't round it. Some of them, they'll ask you to round it, so you can use a calculator. Okay, and we'll take a look at that first thing tomorrow.